So, good morning. This is 12th Physics, Chapter 9, Ray Optics. Today, we are going to start with the topic that is refraction of light through compound plate. Compound plate means, here, children, you can see that outside the medium is A, this medium is B, here the medium is C, and finally, you are having the medium over here again A, right? So it is coming, entering from A medium and it is leaving at medium A, right children? Now, here let's understand the ray diagram first. Here, the ray is incident at the point of incidence that is B, and the angle of incidence is I. So, angle between the incident ray and the normal is your angle of incidence. Now, as the ray of light, it enters from a rarer medium to denser medium, its speed is going to decrease. Its speed will decrease when it enters the medium B. So, as it enters from rarer medium A to the denser medium B, it will bend towards the normal, right? अगर वहां पे कोई दूसरा medium नहीं होता, then the ray would have gone straight like this, right? But there is a denser medium B, so the ray will, and this is your this black is your normal, so the ray is bending towards normal, right children? So you can see your green color ray is the refracted ray, and the angle between the green color refracted ray and black color normal is angle of refraction, that is R1. So this much is clear, right? Now let's move further. Now here children, the black lines, they are all three are normal. They are perpendicular to the plate, right? So they are parallel to each other, children. So here we will see that they are forming Z. They are forming Z. So we know that the alternate angles. So here if we see like this, so this angle is equal to this angle, because which angle they form? From geometry, they are forming alternate angles. So if this angle is R1, then this angle has to be R1. So the angle of incidence on SR will be R1. Why? According to maths, that is alternate angles are, they are alternate angles and so they are equal, right beta? So children, here for plate SR, for the surface SR, the angle of incidence is R1. Is this much clear? Now again children, the ray of light, it will undergo refraction, and for the second case, the angle of refraction is R2 at point C. Right? Again, they are forming alternate angles, that is, they are forming Z, because these two are parallel lines, this is a transversal. So this angle and this angle has to be equal, right? So if this is R2, this angle has to be R2. So here R2 will be the angle of incidence at the phase HL. HL phase, the angle of incidence will be R2, right? And then it is coming from a denser medium to a rarer medium. So it will bend away from the normal, and the angle over here, why we have written I? Let's see. See children, this is perpendicular. This is your normal, right? So, and this is your, this line and this line. They are parallel lines, right children? They both are parallel lines. This we know, this we have studied, lateral displacement. So both the parallel lines, they make an angle with 90 degree, that is with the normal. So both the angles, they have to be equal. So here the angle of emergence here will be I. I hope the ray diagram is clear. Now it's very easy. What you have to do, you are going to apply the Snell's law. So let's apply the Snell's law. Where we are going to apply at point B, at point C, and at point D. We are going to apply the Snell's law. So at point B, it is refractive index of medium B with respect to A. Refractive index of medium B. So B हमने यहाँ लिखा with respect to A. So we will write A in the initial, right? So refractive index of medium B with respect to A will be equal to sin I upon sin R1. Right? This much clear? Right. Now let's apply Snell's law at point C. So for C, which are the two medium? B and C. So here we are going to light is entering in medium C. So refractive index of medium C with respect to B. Right. So what is the angle in B? Angle in B is beta R1. And what is the angle in C? And angle in C is R2. So it is sin R1 upon sin R2. Right? Let's move further. Let's apply the Snell's law at point D. At point D, the two medium are C and A. So we will find the refractive index of A with respect to C. And the angle at C is R2 and the angle in A is I. So it is sin R2 upon sin I. These are your equations, three equations. Let's multiply the three equations. So on multiplying equation 1, 2 and 3, the left hand side will be multiplied and the right hand terms will be multiplied. So when you multiply, you are going to get these all over here and these sign terms over here. So you will see that the sign terms, they get cancelled and you get the answer as 1. So this is the refraction of light through compound plate. And this concept is used in numericals. They show you, they ask you that the light is entering from air, then it is entering from air to glass, then water and again air. So for this type of numericals, we are going to apply this refraction of light through compound plate. Now let's understand a new happening, that is total internal reflection of light. So we know that when light enters from a denser medium to a rarer medium, its speed will increase, right? बहुत dense है, heavy, medium, right? So its speed will increase, and as its speed increases, it bends away from the normal, right? Now, as we go on increasing the angle of incidence, the refracted ray will go on moving away from the normal, and at a particular value of angle of incidence, the ray gets refracted at the angle of refraction, and that is 90 degrees. So children, here you can see that this is the incident ray. This gets refracted like this. So the angle between the normal and the refracted ray is 90 degree, right? So once again, as the light enters from denser medium to rarer medium, refraction will take place and the refracted ray will bend away from the normal. As we go on increasing the angle of incidence, the refracted ray will go on moving away from the normal. And at a particular angle of incidence, the refracted ray will be refracted at an angle of refraction 90 degree. And that angle of incidence is known as critical angle. So for critical angle is what? That is angle of incidence, for which the angle of refraction is 90 degree. So the refracted ray will move along the interface. Interface is the boundary between the two surfaces, right? Now children, if further we increase the angle of incidence, means critical angle से ज़्यादा कर देते हैं अपन और बढ़ा देते हैं, then what will happen? Then if the angle of incidence is greater than the critical angle, then the ray will be reflected back into the same medium, and this happening is called total internal reflection of light. Right children? So what is critical angle? It is the angle of incidence in denser medium to which the angle of refraction is 90 degree in the rarer medium, right? And what are the two conditions necessary for the total internal reflection to happen? First thing is the ray should be from going from denser to rarer medium. Denser से rarer जानी चाहिए ray. Second thing, जो आपका incidence angle है, that should be greater than the critical angle. If the incidence angle is greater than critical angle, then total internal reflection of light will take place. Now let's apply children's Snell's law, and here we are going to apply Snell's law at point C, right? At point C, right children? So here the light is going from denser to rarer. So rarer में जा रही है. So refractive index of rarer with respect to denser, so mu RA, जिसमें जाएगी, right? A I have written, it should be R, right? जिसमें जाएगी उसका आप फाइंड करेंगे with respect to the other. So it will be, यहाँ पे एंगल क्या है I1, यहाँ पे एंगल क्या है 90, sorry IC and 90. So it is sin IC upon sin 90, and sin 90 we know it's 1. So this will become sin IC. IC is the critical angle. Now we know children, according to the principle of reversibility, that mu of rarer with respect to denser is reciprocal of mu of denser with respect to rarer, right? That is reciprocal. So same thing we are applying over here. If we want to find out for refractive index of denser with respect to rarer, then this will be 1 upon this, that is 1 upon sin IC, and 1 upon sin we know it is cosec. So your mu of denser with respect to rarer is cosec IC. Okay, this is the refractive index of denser with respect to rarer. So you have to be careful in the question that you are finding the refractive index of which surface, right? So this is your total internal reflection. Now there are some phenomena in the nature where the total internal reflection is seen. The first phenomena we are going to talk about is the brilliance of diamond. So the glittering, the sparkling diamond you see, right? Why the diamond sparkles, why it is glittering, right? It is because children, the refractive index of diamond, or you can talk first, let's talk about the refractive index, that is mu. So refractive index of diamond is 2.42. Refractive index of diamond is 2.42. Now children, if we find out we know that sin, or let's write first in the terms we know, that is mu equals to 1 upon sin IC. IC is the critical angle. So sin IC equals to 1 upon 2.42, and 1 upon 2.42 will be equal to 24.4 degree. So children, this will be IC. IC value is sin inverse, और इसका sin inverse करेंगे तो बेटा एंगल आएगा 24.4 degree. Now 24.4 degree is the critical angle for diamond. Diamond के लिए IC की वैल्यू कितनी है बेटा? 24.4 degree. That is the critical angle for diamond. 24.4 degree. So it means that if you incident the light at an angle greater than 24.4 degree, so angle of incidence will be greater than critical angle, then what phenomena will take place? Total internal reflection. That is, light once enter, it gets reflected again and again inside, and so the diamond, it sparkles. But why? How? Because children, the diamond is cut in such a way that light which falls on the diamond, it enters at an angle of incidence that is greater than 24.4, and therefore inside the diamond multiple reflection occurs, and so light remains within the diamond and does not come out, and so your diamond sparkles, right? I have already sent, today I will send you the notes also of this topic, right? Next application you can see is that this is a tree, and to a person over here, the eye is over here, tree will appear to be over here. right? So this is an illusion, right? This happens mostly on hot summer days. We feel that there is some water on the road. We feel, right? This is mirage. That is known as mirage. So what happens in summers, children? The summers, as they are very hot, the temperature of the air which is near the earth, यहाँ पे जो air है उसका temperature will be high, right? As the temperature is very high, the air over here, it will get heated. Air will get heated. So as the air will get heated, here you are going to have a layer of warm air. You are having a layer of warm air. But as you go at higher altitude, the temperature decreases. So the air which is present at the top layers, it is comparatively cooler air. It is comparatively cooler air. So cooler air, the refractive index will be less. Cooler air, the refractive index will be, sorry, it will be more. The refractive index will be more क्योंकि cooler air क्या heavy होगी, heavy है, so उसका refractive index density ज़्यादा होगा, so its refractive index ज़्यादा होगा, so it is denser, and warmer air light हो जाएगी ना बेटा, it is light, so it is refractive index is less and it is a rarer medium. Now be careful, children. The ray of light is going to enter from denser medium to rarer medium. So first condition of total internal reflection fulfilled? Yes. Second, so what happens is when the light enters from a denser medium to a rarer medium continuously due to the refraction of light, the ray of light, it enters from denser to rarer medium, and so it starts bending away from the normal, and there are many layers. एक बार नहीं होता है, ऐसा बहुत बार होता है, बहुत सारी air की layers है यहाँ पे, right? So through every layer the air gets refracted, and when the angle of incidence becomes greater than critical angle, total internal reflection takes place, and finally to the person who is standing over here, to him the image forms at this point, at point I. So this is the mirror image of the object O. This is our object O, and the mirror image of the object O is over here, that is I. So an inverted image of the tree is formed because of the reflection from the pond of a water. But there is no water in the desert, but it appears that there is some water over there, and so inverted image appears to the person standing at point E due to total internal reflection as the light is entering from a denser medium to a rarer medium. ठीक है बेटा? Next is, children, total reflecting glass prisms. These are what? These are your glass prisms. These are your glass prisms. They are designed in such a way that the light can be turned through 90 degrees. So here you are inciding the light like this. So it is getting reflected and it comes out this. So you have turned the light at an angle of 90 degrees. Here you are inciding the light at this angle. It gets reflected, total reflection takes place, and it comes out like this. So it had turned 90 here, 90 here. Total turning is 180 degree. So how does this happen? So this happens, children, that this is made up of, these are glass prisms. So the refractive index of glass, that is mu, is 1.5. So the critical angle we can find out, the critical angle sin IC can be find out by 1 upon 1.5. That is 1 upon 1.5, and if we find IC will be equal to sine inverse of 1 upon 1.5, and that comes out to be 42 degree. 42 degree. So IC is 42 degree. So here you are inciding the light at an angle of incidence, and that is 45 degree. So 45 degree is greater than 42 degree, right? So angle of incidence is greater than critical angle. So what happening will take place? total internal reflection. So totally the light will be reflected back, and you are going to get the light which is entering from point A. It will be undergoing total internal reflection and it will appear at A dash, right? So similarly, the light gets turned at 180 degree, right? Next is the optical fibers. Now, optical fibers, we are very well known about the optical fibers, the fibers that are used in the transmission of signals and that all, right? So, optical fibers, children, they are a large number of fibers which are made up of glass or quartz, and the diameter of the fiber is very very low. It is about 10 to the power minus 4 centimeter. इतना कम diameter होता है उसका बेटा, और उसका जो refractive index होता है of the optical fiber, that is of the order of 1.5. See, glass का जो refractive index है, because it is also made up of glass only, right beta? And this core, this is made up of glass or quartz, and outside this we have coated it with another medium. That medium we call it as cladding. क्या बोलते हैं बेटा उसको? cladding. उसको coating करते हैं, right? And the material of the cladding has lower refractive index. उसका refractive index कम होता है, right? So it means denser, rarer, and here also rarer. So it means light is entering from denser medium and rarer medium. So first condition of total internal reflection satisfied, children? Yes. Now what we need to do? We just need to incidence the light at an angle that is greater than critical angle, right beta? Now see here carefully. Here you can see two rays. First is this red ray, right? Now red ray is incident at an angle that is critical angle. Theta c लिखा हुआ है इसमें, ठीक है? Critical angle पे होगा तो then we know that the angle that the ray will be refracted at 90 degree. तो ray ऐसे बाहर आ जाएगी, right? Similarly, you can see here a purple ray which is again incident at an angle that is critical angle. So, ये भी 90 degree, that is along the interface, right? Now, the rays in between, they are having their angle of incidence which is greater than critical angle. So, greater than critical angle. So, this is the second condition for total internal reflection, है ना बेटा? तो लाइट क्या होगी? रिफ्लेक्ट हो जाएगी, अंदर ही रिफ्लेक्ट होती रहेगी, है ना बेटा? So light entered like this, will be reflected back, reflected, 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 reflected inside, and it will travel like this. Okay, so the light travels through the optical fibers with the help of total internal reflection. And here by this method, there is no loss of light, right? And so this optical fibers, they are used in the transmission of electrical signals. They are used in medical field also, right? Endoscopy अगर आपने करवाई होगी, you might have seen that. And optical fibers, they are also used in telephones, right? Because the message carrying capacity of a fiber is very very high. So these were the children application of total internal reflection.